Greetings, everyone. Hope you're all well. So today is the last day of our instructional component of this workshop. Tomorrow we'll do some more practical exercises. I hope that you found yesterday's practical session useful and you were able to try and apply some of the methods to your own data. So we're going to get moving on again today with the final two sessions of this capacity building workshop. Just to give you a recap of where we've been on this journey so far, we had instructional sessions on Monday and Tuesday, and we covered matters relating to concepts and ideas relating to assessment of completeness, understanding both the numerator and denominator, as is increasingly clear to you, I hope now, that even though the idea of measuring completeness is relatively simple, the devil lies in the detail of how one actually works with those numerators and denominators. We talked a little bit about the impact of COVID-19 on estimating completeness, even as the epidemic starts to run its course, we hope. The impact of the epidemic is going to echo through those data, through our civil and vital registration data, for many years to come as we try and unwind the impact of COVID-19. We talked about adjustments to the numerator for delayed registration. And then on Tuesday, we spent quite some time talking about how to go about estimating completeness of birth registration. And within that, particularly talking about, or learning how to use the suite of spreadsheets, which has been provided along with the guidelines which have been drafted for people in the region to try and improve the estimation of their completeness of vital registrations. So what we're going to be doing today is we're going to be finishing off the estimation of completeness of birth registration. I want to talk about three alternative approaches which you might use to derive an estimate of the denominator, which could be used to assess your completeness. We're going to talk about using data from a census to derive estimates of number of births in years prior to the census, using what demographers call reverse survival approaches. We're going to talk about the possibility of using fertility rates from a census or a survey, for example, a mix or a DHS, applied to estimates of the numbers of women, again, to derive a point estimate of the completeness of birth registration. And finally, I want to reflect on the possible uses of administrative and or health data to estimate completeness and to use those data in one's denominator. We're then going to take a 10 or so minute break between the two sessions of today. And then I'm going to, the final session is going to be talking about estimation of completeness of death registration. And as I've said, much of what we have covered in this workshop applies with very minor modification to the estimation of completeness of death registration. And so we will be talking about how to use the UN World Population Prospects data as the denominator for all deaths, under 5 deaths, infant deaths. We'll talk about using alternative estimates for the denominator, sourced from other population projections, for example. And then we're going to take a kind of a hard right turn into a completely different approach, which might be used to provide estimates of the completeness of adult death registration. And this is going to give you a sense that maybe there are some fairly advanced demographic techniques which might be able to shed insight and to allow you to cross-check at least portions of your estimates of completeness. So when we talking about birth registration completeness. The population projection type approaches which are adopted, so for example, the UNWPP, or in fact, any population projection which is based on a cohort component projection methodology. Those approaches, by their very design, enforce a consistency between population numbers and estimates of either births or deaths. And that is the reason why we, by and large, recommend their use, is that the underlying methodology of a cohort component population projection method is designed to ensure that consistency. But there are other approaches that do not rely on population projections to estimate the denominator. And at times, or as a further cross-check on your estimates, or as a supplementary investigation, there are methods and techniques which might be able to be applied, which might be of use. Although, I mean, as I have tried to emphasize, that your starting point should always be the UNWPP. You might want to then progress onto using subnational population projections produced by your national statistical agency. But there are still, as I say, these other three approaches which at least require to be mentioned in order to best understand the completeness of one's birth registration. And so we're going to be talking about those three distinct approaches. We're going to be talking about how to estimate past numbers of births from a census age distribution. We're going to be talking about the application of a set of derived fertility rates from another source to a population age structure, and then finally making use of that administrative or health data. So the first of these three is what we would call the estimation of the past numbers of births from a census age distribution. Demographers would refer to this as a reverse survival type approach. And the logic of a reverse survival approach is relatively simple, is that we can note that in a census, the enumerated population of children, both sexes, by single years of age, between ages 0 and 14, represent the survivors of past births. Okay, so for example, those who are enumerated to be aged 0 at the time of the census must represent the survivors of births which must have occurred in the 12 months before the census. Okay, and similarly, those aged 1 would be the survivors of the births between 1 and 2 years before the census. And similarly, the population of women enumerated in your census of women aged between 15 and 64 will represent the survivors over the past 15 years of all the women who were of childbearing age, which we would define to be 15 to 49 years of age over that period. So someone aged 64 at the census would have been aged 49 15 years ago. And so what we're going to try and do is use this information to try and produce a sequence of the estimated number of births in that population, which gave rise to that population of children. Obviously, those children have to be born to mothers, which is why we have to worry about what the population of women of childbearing age in all previous years is. It must also be emphasized, and it will become clear in the conceptual demonstration, which I give just now, of this approach, that while the method is designed to estimate the level of fertility implied by the census and population age structure, in order to produce that estimate of fertility, it does, in the process of doing so, produce a tabulation or a series of estimates, a sequence of estimates of the past number of births from that census age distribution. And so the reverse survival approach, which we're going to be talking about today, makes use of that insight that the children aged 14, who are aged between 14 and 15 at the time of the census, must, to some extent, well, must by definitionally represent the survivors of births 14 to 15 years ago. But obviously, what we'd need to do in doing this is we'd need to account for mortality. And we know that mortality is not only highly age determined, but also changes over time. And so we're going to need to make assumptions about past mortality rates, both of children and of the women of childbearing age. And we also, in order to apply this method, need to make an assumption about the age pattern of fertility rates over time. We're not obviously, well, not necessarily obviously, we're not going to make use of information about the level of fertility rates, because that is in fact what we're trying to produce when applying this method, and we're trying to get an estimate of what the total fertility rate is. But we need to make an assumption about what the shape of that age distribution of fertility is, drawing on past censuses, surveys, the UNWPP, etc. And so we're going to make use of those population age distributions of young children under the age of 15, as well as the number of women of childbearing age, to generate an estimate of the level of fertility. And that level of fertility, as I've mentioned, in the process of producing that estimate of the level of fertility, produces an estimate of the number of births over the 15 years, and each of those 15 years implied by the census data. It's also worth just noting that we do not apply this method for after the age of 15. In other words, for children over the age of 15, or trying to get estimates more than 15 years before the survey. And the reasons for that are twofold. Firstly, if we assume that childbearing typically runs from age 15 to 49, as demographers tend to do, if you go back more than 15 years, you've got the problem that suddenly your births are the product of some of the births which happened earlier. So if you go back 16 or 17 years, some of your births now might be the result of births which might have happened in the period which you're trying to estimate those number of births. And so one introduces a degree of circularity into the process of doing this estimation. And the second reason is perhaps more important, is that after age 15, migration of young adults starts to become material, and that can be a major impediment to making use of this reverse survival approach. So the method itself is fully described and implemented in a manual produced with financial support from the UNFPA about a decade ago, a manual called Tools for Demographic Estimation. It's an online website with spreadsheets and implementations of a variety of methods for estimating demographic parameters, particularly for those in developing countries. But three particular cautions apply when one might be considering adopting a reverse survival approach to estimating the number of births in the past. The first is that the method is completely dependent, and I've underlined that because it really cannot be emphasized enough, on the accuracy and the completeness of those census data. If there's under-enumeration by age or differential under-enumeration by age, in other words, different age groups are underestimated to different degrees, this will distort the estimate of the number of births in previous years. What we will see, though, is that in general, where if there is under-enumeration, if it is broadly consistent, both by age of the children and by the age of the mothers, the estimates of fertility which one comes out will still be reasonably plausible and provide a good handle on your level of fertility. But if there's a differential under-enumeration by age, we will tend to get some possibly rather odd estimates of the number of births in previous years. And so what this requires as a first step of trying to estimate births using this approach is to be entirely convinced in one's own mind that the accuracy and the completeness of the census data are fit for purpose. And that would involve a series of detailed investigations to examine the age and sex structure of the population relative to, say, what is implied by the UNWPP for the census year. The second problem which we are trying to get to is that the method produces estimates of births in 12-month periods ending on the census anniversary. The reason for this being that if you imagine your census was conducted on the 10th of October 2011, and you enumerate a population of children under the age of 1, who in other words are age 0 last birthday, those children could have been born any time from the 10th of October 2010 to the 9th of October 2011. And so the estimate of the number of births, which one derives from that, is going to relate to a definition of the census year rather than a calendar year. But because our civil and vital registration data are routinely tabulated by calendar years, we need to interpolate between the estimates of births in each of the 12-month census periods, the census years, to recenter those estimates onto the middle of a calendar year in order to get as accurate an estimate of the completeness as we are able to do. As I mentioned briefly just now, the method of using reverse survival techniques assumes that migration can safely be ignored. In general, in most populations, this is probably acceptable at a national level, but it becomes increasingly tenuous at smaller geographical units. So as one goes down on a spatial scale to increasingly fine spatial levels, migration becomes a greater and greater determinant of what your population is and the enumerated size of that population. And so while the method might work reasonably well in the context of national estimates, it does become increasingly tenuous at subnational levels, or where there's a significant migration of children under the age of 15. And this is then becomes a matter of judgment from the user as to how significant any levels of migration at, say, an interprovincial level or a rural-urban differential are in terms of deciding on whether to apply this approach or not. In order to apply the method, as I've said, given the sensitivity of the method to the accuracy and the completeness of the census enumeration, it's essential to cross-check the estimates of the number of births against those from another source before using them as a denominator. And here, the obvious counterfactual check would be the data from the UNWPP. So you could look at the estimate of births produced by the reverse survival method and then compare that estimate of the number of births against the UNWPP just to make sure that the estimates are broadly consistent. But if these data are usable and you are satisfied that the census data is complete and is accurate, it will allow the derivation of expected numbers of births by year for up to 15 years before the census, possibly by sex or by subnational geographies. And so I want to just give you a flavor of how this method might work by using an example from the 2008 census of Cambodia. So let's get my laser pointer up here. So these are the essential data which need to go into any estimates of reverse survival estimates of the number of births in our population. On the right-hand side here, we have the number of children enumerated at each age from 0 to 14. So that's saying that in the Cambodia 2008 census, there were 281,260 children aged 0 or under the age of 1. And likewise, for the population of women in 5-year age groups, there were 160,590 women aged between 60 and 64. A first check on these data would be to simply plot the number of children under the age of 15 over by age, which is this first plot over here, and that's age 0, and you can see there's an odd kink in the data there. I've marked it in red in the data, is that there's seemingly comparatively few children aged 9 and 10, and something of a heap on age 9 and 11, and something of a peak around about age 10. And that would seem to indicate a fairly conventional pattern of age heaping at the age of 10 in a census. And so one of the problems we're going to come up with is that where there are these kind of erratic trends in your age distribution of children by single years of age, these peaks and troughs will come through almost mechanically into your estimates of the number of births and your fertility rates going forward. We can also plot the number of women by 5-year age group from 10 to 14 up to 60 to 64. And this seems to be a very regular distribution. There's one particular drop there of women aged 30 to 34 at the time of the 2008 Cambodia census. And that is not actually a problem. That is a real artifact in the data. That much smaller number, it's almost half the number of women aged 30 to 34 relative to women 25 to 29, represents the births which did not happen, if you can imagine it that way, during the Khmer Rouge period in the Cambodian history in the 1970s. And so that, even though it appears to be an anomaly in the data, is a real effect because of the impact of that particularly tumultuous period in Cambodian history. When we apply the methods, and I'll step you through the spreadsheet just now. When we apply the method and we produce an estimate of the total fertility rate, the method produces estimates of the TFR which are not entirely problematic. So the blue line represents the estimates of the total fertility rate from the Cambodian 2008 census, and we can see here that estimate of the total fertility rate comes from the enumerated population age 9, that's the enumerated population age 10, that's the enumerated population aged 11, which is 1997. And you can see how that original distortion in the age profile of young children echoes through mechanically into our estimates of the TFR. When we compare those estimates of the TFR relative to those which one could derive from either the United States Census Bureau, which does international population projections, or the UN Population Division, we can see that certainly for the period 1993 till about 2001, the estimates of fertility implied by this method are not particularly different from those two. And so we have some degree of confidence in the applicability of the methods at those ages. What we do see, however, is that there's this, the implied level of fertility from the census in more recent years, from about 2001 through to 2008, those estimates of the total fertility rate tend to start falling increasingly below those estimated by either the UN Population Division or the US Census Bureau. And that is probably an indication that in a lot of censuses, particularly in the developing world, that young children particularly are under-enumerated. And so on the one side, one says, well, this is a method which might work and might usefully be able to provide us with an estimate of the number of births in this population, because if the TFR is more or less right, well, then they want to hope that the estimate of births might be more or less right. However, if we look at the number of births implied by these data, the annual number of births here is shown again from the reverse survival for Cambodia in the blue line, and the UN Pop Division estimates from the UNWPP of the number of births is shown by the green line. And here what we can see is, again, we can see that from 2001 onwards, those estimates of births is typically quite substantially lower than that indicated by the UNWPP. I mean, that's about a fifth or a sixth less births by 2007, 2008. And that would point to that well-known issue of the under-enumeration of young children. But certainly, if we wanted to, we could use this information probably from about 1996 to 2001 about as a useful approximation, as a useful cross-check on the estimates of the number of births. And so this is another method which can be applied, and also along the way gives one insight into the quality and utility of one's census data in order to be able to produce an estimate of births. But if you are in a country which has an almost entirely complete and accurate census, this method should provide a useful cross-check both on the estimates of the denominators which you might get from the UNWPP, as well as an alternative set of estimates which one might want to be able to derive. So I want to just briefly, and I've put a copy of the spreadsheet into the instructional material directory folder of the Google Drive, just to give you a flavor of how one might be able to use these, use this information. So let me just put this up here and go up a bit. So this is the spreadsheet which accompanies the volume Tools for Demographic Estimation, which I referred to earlier. In every case, there's a link back to the original
coverage of birth rates. Yeah.
Sorry? Okay. Let's go back. So there's a link back to the original published volume, Tools for Demographic Estimation, to the original page, which gives very detailed descriptions of the methods and how to apply them, and exactly how to use these spreadsheets. I must just, as a very quick diversion, just alert that the website which hosts the Tools for Demographic Estimation is currently experiencing a problem with its content management system. It's a version of Drupal which hosts this project. And until we are able to update the underlying software which manages this project, the website is most functional when one uses Firefox as a web browser rather than either Chrome or one of the Microsoft web browsers. There's some very technical issues associated with the reproduction of formulae, amongst other things, on those web pages, and the rendition of formulae on the web page, which we are having to resolve at the moment. But for your purposes, and I can't give a detailed lecture on demographic estimation. What we can do with this spreadsheet is a kind of very generic vanilla type implementation of the reverse survival method, is that we would enter the country's name there, because that will become important for reasons which will become clear just now. We enter the official census date associated with that census. So the official census date of the 2008 Cambodia census was the 3rd of March 2008. We are going to just use data from the UNWPP and the fertility data from the UNWPP to estimate those, both the age pattern of fertility as well as the level of mortality through to 2008. One of the other sub-projects associated with the demographic estimation website is to recast these using the 2019 UNWPP, but the effects are going to be fairly limited because we're looking at data going, in this case, going back from 1993 to 2008, and the revisions in subsequent editions of the UNWPP are not going to be that material for these purposes. We would then, on the method sheet over here, bigger, we would enter in the green cells here our enumerated population of children. We can see that peak there at age 10 again. I enter the enumerated population of women by age group. We can see that particular impact amongst those aged 30 to 34 in the data. And if one uses a generic vanilla flavored model where we just can say, let's just use the UNWPP. We're not going to make use of all the bells and whistles which this spreadsheet does allow you to otherwise implement. Crucially, what it produces is not only the estimates of the total fertility rate for each year going back in time. You can see these years are centered 6 months before the census, so in about September of 2007, covering the year from March 2007 to March 2008. We can come up with those estimates of fertility, but more importantly, we can get an estimate here, and it's produced directly by the reverse survival technique, of how many births we expect in the population in each of those years. This first one running from March 2007 to March 2008, and centered in the middle of that year, of that census year, which would be about September 2007. So the crucial output for our purposes would be this estimate of the number of births. And someone asked, I think it was in the practical session yesterday, what is this other sheet in our in the resources Excel workbook, which is there, and what is it for? And this is exactly what that sheet is for. What we will note is that the output from the reverse survival application is that these births are firstly arranged in descending order of time, so 2007, 2006, 2005, and that is because those births relate to the children arranged in conventional age groups. We also note that these estimates of the number of births are centered on years in September, whereas our civil and registration vital statistics system would want to say how many births occurred, say, in calendar year 2007 or calendar year 2006, in order to be able to more directly compare them with our estimates or our derived data, extracted data from the CRVS. And so what the final tab on the resources spreadsheet does is allows you automatically to take data, say, from the reverse survival output. This block of data here is in fact simply that block of data from the output. So let me just show you up there, 292,000 down to 407,700. And what this tab does is it takes those data, and if you say the data are sorted in reverse order, which is the order in which they are routinely provided by that other spreadsheet, this tab will take those data and recast them not only in terms of ascending conventional date order now, but will also interpolate those values to the middle of the year. So that value of 408,960 is going to, which is going to be centered on mid-1994, so that'll be the estimate of births in calendar year 1994, is a linear interpolation between those two values for the two different census years. And so what this spreadsheet or this sheet of the workbook does is allows you to take data which is presented from any source in an unconventional way, either arranged by reverse order, or you could select it saying it's arranged in conventional order, but maybe those estimates are not centered at the middle of a conventional calendar year, as is the case here. And what this tab of the spreadsheet does is to rearrange and interpolate those values so that we can get a sequence of interpolated values centered on the middle of each year. And those could then be used in an estimate of deriving an estimate of completeness. And you remember that when we looked at the results from this application of the reverse survival method, we said that probably between about 1997 and 2001, 2002, that by and large, those estimates of the number of births might be largely robust. And so therefore, we might want to be able to use those estimates as one of as a denominator in our construction of our completeness estimates. And so this is just, you can think of this as another string to your bow, so to speak, of how one might want to go about estimating completeness, that we can make use of other data which might be available to you. And you're not necessarily obliged always to use the UNWPP or other population projections. You might also want to use this as a process of triangulation to be able to reflect on the quality of your census data. We know the census is of crucial and vital importance in across the developing world. It provides a basis for sampling frames, for surveys. It provides a key range of crucial information. And so this might be a useful other way of triangulating all that information into something which you have a greater understanding of the demography of your own country, and along the way might be able to produce some further estimates of the completeness of your birth registration.
What are two music work?
Sorry? Was that a question, or was that just a random noise? I think it was probably just random. The second approach which we can adopt, which doesn't make use of population projection data, is to estimate the number of births in a population, and that could again be by sex or by subregion, by applying a set of fertility rates which have been derived from another source, from a DHS, a mix, a census. Sometimes in some countries, a general household survey will ask questions about fertility of women as well. And so there are a wide variety of possible alternative sources of a set of fertility rates, which are routinely collected. And here, particularly, as I say, the census, the DHS, and mixed surveys might all well be able to offer something which will allow us to estimate the number of births in the population. Now, those fertility rates could be based on direct calculation, say from a DHS or a mix or a survey, or if your census was known to be particularly good and robust and accurate and complete, you might be able to estimate fertility rates directly from the census. And that might be something which is worth investigating as well. Or even if your census is less accurate or less complete, we can use a demographic technique called the relational Gompertz model. It's hyperlinked there back to tools for demographic estimation. That in itself would be a 2 or 3 hour lecture on how to use it, but it's a resource which is there and available for demographers across the developing world to try and apply it. And that model can often do an excellent job in correcting for known deficiencies in the collection of data relating to both lifetime and recent fertility in a census. And so we might be able to get estimates of fertility directly from a census or a survey, or indirectly using a relational Completeness model applied to a census. But in general, given the assumptions required to derive estimates of age-specific fertility rates from a census, and because we know that barring exogenous catastrophes and exogenous events of enormous significance, fertility rates and the pattern of fertility rates tends to change only very slowly. And so unlike with the number of births in the population, which can actually make a much greater difference to your estimates of completeness, we don't recommend that you recast fertility rates to be exactly lined up on the middle of the year. The precision is really not worth it. You end up changing your estimates of your age-specific fertility rates in your third or fourth decimal place. And so all we would generally suggest doing when you're working with census data is you take your estimates of fertility from that census, whether it's derived directly or indirectly, and apply those rates to the number of women by age group at the mid-calendar year closest to the date to which those fertility rates are deemed to apply. In the context of a DHS or a mix or similar surveys, the DHS particularly makes available code in a variety of statistical platform codes or macros to allow the direct calculation of age-specific fertility rates. Usually the age-specific fertility rates from a DHS or a mix are calculated over a 3-year period, over a 36-month period, because the sample size of those surveys is relatively small, and the estimates from a 1-year estimate are usually too variable and erratic and subject to noise than is generally regarded as being useful. But what we can do with a DHS or a mix is we can calculate for the 3 calendar years before the survey, what were, over that period, the 3 years, what was the pattern and the level of age-specific fertility rates from that survey. And if one is calculating a set of fertility rates over a 3-year period, over 3 calendar years, well then on average the births in those last 3 years would have been about 18 months into the 3-year period, which would be exactly in the middle of the 3 calendar years. And if you're working on a calendar year basis to derive those rates, you will actually produce fertility rates centered on the middle of a calendar year. And the way we'd do this is we'd take we'd derive an estimate of the true quote-unquote number of births by applying those observed fertility rates from a DHS, from a mix, from a census to an estimate of the population of women in each age group at the time to which those fertility rates would apply. So the births at some time t, say the middle of some calendar year, would be the sum of all the age-specific fertility rates in some age group I at that time, multiplied by the number of women in that age group at that time, and you'd sum that over all age groups. To give a very clear and very simplified example of this is data from the South African 2016 Demographic and Health Survey, where we were able, using the materials made available by the DHS, to calculate fertility rates for the calendar years 2013, 14, and 15 combined. And because that's a 3-year period running over 3 calendar years, those estimates would apply to the middle of 2014. And so we can get an estimate of the age-specific fertility rates per 1,000 women at mid-2014 for each of the 7 age groups of women of reproductive age. These data show a very conventional pattern of relatively high teenage fertility. It peaks amongst women in their 20s to 30s and then falls off very rapidly. And those data implied a level of fertility of about 2.67 children per woman, which is not entirely out of keeping with our with our understanding of the trajectory of the South African fertility decline. We could also then take, for example, the results from our National Statistical Agency's mid-year population estimates. Every year, Statistics South Africa produces a set of numbers of the population, saying how many people are in the population at the middle of each calendar year. And those data are published on the internet in a published report, and we can go and consult one of the tables in that report, and we can get a number of women aged 15 to 19 as of mid-2014 from that estimate. And we can extract those 7 numbers from the Stats South Africa mid-year population estimates report. If we then apply the formula here on the previous page to those data, this says that the births in any age group is going to be the age-specific fertility rates in that age group multiplied by the woman. And that's exactly what we do here. If we take that number of women multiplied by the age-specific fertility rate per 1,000 women, that tells us that there were just under 200,000 births to women aged between 15 and 19 in South Africa in 2014, and about 4,000 births to women aged 45 to 49. And if we sum all those estimates of the births in each age group, as implied by the previous formula, that would indicate about 1.232 million births, which is the number of births you'd expect if the age-specific fertility rates from a DHS applied. We know the DHS is generally highly accurate and highly reliable. And if we applied those estimates to the population, say, produced by our National Statistical Agency, that would imply a total of 1.232 million births. And just to give you a sense as to kind of how robust this might be, from the resources spreadsheet in the generic example with which the spreadsheet is populated, we can go back and just check here. Let's just put up the resources sheet under completeness over here. This is the estimate of births in South Africa. We could look up those numbers of births in South Africa over there, which are those 2 numbers over there from our registered data. Those were the data extracted from our civil registration vital statistics system. The UNWPP estimates of the births in 2014 were 1.205 million, and we had previously derived estimates of completeness of 79.2% on a year 0 basis, and an expectation that when all births are finally registered, about 85–86% of births would be registered in South Africa in 2014. On this alternative basis, which we've just derived here, we can get an estimate of saying that there's 1.232 million births. We can compare that against our registered year 0 births in 2014 and our expectation of the ultimate number of births in 2014 that will ultimately be registered. And we'll come up with just a slightly lower estimate of completeness. Obviously, if we've got more births expected in our denominator relative to the UNWPP, that will mechanically push the estimate of completeness down a little bit. But in general, these estimates of completeness are really not that distinct from each other. I mean, given kind of the information one's relying on to estimate completeness, either the results from a model, say the UNWPP, or Stats South Africa's mid-year estimates and the results from a survey, we can now be pretty certain that pretty much no matter what data we use, on a year 0 basis, in other words, births registered in the year in which they occurred in 2014, the answer lies, the estimate of completeness lies in a range of about 1.5%, of 77.5% to 79%, and about the same magnitude of difference on an ultimate basis, being about 84% and 85.5%. And so this is also an exercise worth doing. Why? Because what we've managed to do is say, well, on a completely independent basis from the UNWPP, we haven't used their fertility rates, we haven't used their population estimates, we have constructed what we think might be a reasonable estimate of the number of births in our population in 2014, which is, as I say, is completely independent from that of the UNWPP. And we have managed to produce estimates of births which are incredibly similar to each other. I mean, those differ by what, 27,000 out of 1.2 million. It's a very small discrepancy, and that produces estimates of completeness which are certainly, you know, fairly close to each other. And so that allows us to be even more certain as to what we think the level of completeness of birth registration in South Africa was, say, in 2014. And so this is also an exercise worth pursuing as and when you are trying to estimate the completeness of birth registration data. And yeah, in this context, you know, the estimates which one could get are from a DHS. The DHS in most countries run every 5 or 10 years. So you might well have a long sequence of DHS data to work with. If your National Statistical Agency produces mid-year population estimates independently of the UNWPP, that would give you an alternative set of estimates. And between the two, one can actually start to get a greater degree of confidence in the reliability of your estimates of completeness. And that is one thing which one obviously is looking for, is to know that no matter what data you throw at the problem, you will come up with a very similar estimate of those measures of completeness. Finally, I want to just talk about the third aspect, the third approach which one might use to try and estimate the total number of births in the population. And the first of these is to make use of administrative data. The second is to make use of health data. And in the case of administrative data, in a situation, in a country, in a province, in a territory where school enrollment is almost universal, an alternative might be to try and make use of administrative data on school enrollments by the age of the child. Okay, and this would require working with your Ministry of Basic Education or Ministry of Education in order to get them to say from their administrative data systems, and that is presuming that there is an administrative data system which keeps track of every learner in every school in the country, they should be able to produce a tabulation of enrollment in schools, not by the grade or the form or the class in which the learners and scholars and pupils are enrolled, but by the age of those scholars and pupils. I must just flag that where it is either known or suspected that significant gender disparities in school enrollment are known or suspected to exist, that you must take particular care in applying administrative data, because if, for example, young girls are routinely not in school, then what you are picking up in your school enrollment data would be very largely males from your administrative data, and then you'd have to start worrying about what you compare that estimate of enrollment might be. And so in situations where, as I say, this particularly applies where school enrollment is almost universal for both sexes, for both males and females, boys and girls. And what we can do with these data from, say, your Ministry of Basic Education is to estimate the number of children of school-going age in total from the administrative data on school enrollments by age. Because firstly, not every child is going to be in school. And so what we can do is we can take those numbers of school of enrolled school-going children from the administrative data system and inflate that number by what we'd call an age-specific enrollment ratio, which you might be able to source from a census, or you might be able to source from other large-scale survey data. And what one effectively is saying is one takes the number of children enrolled in your school system from your administrative data in your numerator over there, and you inflate it by the ratio of the number of children of that age in the census relative to the children of that age in the census who are reported to be enrolled in school. And by doing so, what one is effectively doing is one is then inflating the number of enrolled children by the reciprocal of an age-specific enrollment ratio to get an overall estimate of how many children are aged X. So you can imagine that if you had 100 children in your population and 90% of, so you had 100 children in your administrative data set, saying they were enrolled at a certain age, but your census or another large-scale survey told you that 90% of children of that age were enrolled in school. If you divided the 100 by 90%, it will give you 111. That would give you an estimate of your total number of children of that age in your population. And what we could then do is, in fact, use that in a reverse survival analysis, as we did previously, to derive an estimate of the number of births that must have happened in the past to give rise to the number of children of school-going age, which you now estimate in your population. So this can be a quite technical form of assessment. In some situations, it might not be possible. Certainly in South Africa, trying to get data on school enrollments by age of the learners is next to impossible from our Department of Basic Education. Even though we know they have the data, they're just not willing to provide researchers and academics and people working in the space of civil registration assessment with those tabulations by age. That they are happily provided by form or grade, but that doesn't help very much in the South African educational context. But I just want to flag this as, you know, the kind of lateral thinking which one can engage in to say, yeah, if you're really lacking other data on a denominator which you want to use, and we know, for example, in the practical session yesterday, the attendee from Palau very, very politely and kindly pointed out to me that the UNWPP doesn't produce estimates for for some small island states such as Palau, and so you might want to think about using these kind of approaches, either making use of census data, survey data, in order to be able to try and derive an estimate of the number of births in previous years, where you don't necessarily have a particular benchmark from the UNWPP. Likewise, and this is my final slide for the first part of this morning, is to think about how one might make use of health data relative to in order to derive some estimate of your denominator. It's not provided on the slide, but I would hope it would be intuitively obvious. But if one could imagine that every child in your country was delivered within a health facility, well, then there should be health facility records, which would give you directly the number of births which occurred in your country over any given period of time. Of course, in most developing countries, not every child is delivered in a health facility, whether it's a hospital or a clinic. And so in a lot of cases, that will not be appropriate. But in several instances, and in some parts of the developing world, it might be the case that almost every child is delivered in a hospital, and that might be a useful alternative estimate of the number of births in your population. But a more interesting idea is to see whether you can't make use of routine vaccination data collected by your national ministries of health to provide an estimate of the number of births. But in order to use, say, vaccination data successfully in trying to estimate the number of births, you need to make sure that several criteria are met. The first is that if you're going to use the count of the number of doses of a particular vaccine, which have been administered over a period of time, you really want to make sure that that vaccination is near universal in its administration. So it might be, for example, polio drops administered at birth. Okay, and if you can count the number of doses of polio drops administered at birth, that might well give you an alternative measure of the number of births which must have taken place. But you'd also need to ensure that the record keeping of those vaccinations and the record of the vaccinations kept by the Ministry of Health is complete, is accurate, and is timely. If we want to most accurately estimate the number of births, if you think about it, you'll realize that the vaccine chosen for tracking or chosen to estimate your number of births, you'd really want it to be one of the vaccines which is administered either at birth or very close to the period. So you don't necessarily want a vaccine which is administered first at the age of 3 or 4, because the only people who will get the vaccination at age 3 or 4 are the survivors of the births 3 or 4 years ago, who are now eligible to receive that vaccination. So ideally what you want is a vaccine which is administered either neonatally or perinatally routinely in your set situation. And you'd also want to prefer that it's a single dose vaccine, or if it's a multi-dose vaccine administered over multiple periods of time at multiple ages of that young child, you really want to track it as the first dose of a multi-dose vaccine. But that then requires, again, a layer of sophistication and accuracy of the vaccination records being kept by the Ministry of Health to say how many first doses of a vaccine have they administered perinatally or neonatally to young children over a given period of time. The point about these last 2 slides is not necessarily to say, kind of here is an implementation of these methods, as I've tried to give a flavor of the kinds of data which one is using now with these these final approaches, is really thinking out of the box, is thinking laterally of what other data do you use when you have no other data. And obviously the structure and availability and utility and accuracy of those data are going to be highly variable from one setting to another. And so one can't offer general and routine guidelines to it. But the point of these 2 slides is rather to plant the seed in your mind to say, what else might we be able to make use of in order to get a handle on something which you might not be able to get routine data on? To give you an idea, let's go slightly off piste at the very end of this afternoon's first session. In the case of South Africa, one of our problems has obviously been in recent years COVID-19 and the effects of COVID-19. And we have a population register which is updated in real time, which we have been able to access in order to be able to track excess deaths from COVID-19 in near real time. However, what we don't get from those data are a whole lot of the ancillary information, which is captured captured and processed only much later by our National Statistical Agency. And one of the things we don't get is a good measure of where the person who died lived. And if you're wanting to track excess mortality by province, that really matters. What we were able to do, however, is we were able to approach our Elections Commission and say, please, for those people who have died, and to avoid confidentiality concerns, obviously in that case, please tell us where the identity numbers of these people who have died recently, where they were last registered to vote in either a national or a provincial or local government election. And they were able to give us down to a 500 by 500 meter grid of where that person was last registered to vote in an election. And we were able to use that information to get a far more finely grained picture of where the deaths from COVID-19 in South Africa are taking place. And really, the point of that anecdote is not to say that you should run off and go and approach your Elections Commission and ask whether you can use their data if you think that nearly every adult is registered to vote, for example. But it is to say the power of lateral thinking, of saying, in your country, what other thing might be going on which will allow nearly universal collection of data on people, which might be allowed to be used in some way and to be implemented in some way to track what you're trying to track. In your case, in the case of this week's workshop, the registration of births and deaths. So please, you are only limited by the scope of your imagination. What other data you can imagine in your country, in your setting, might be available to help you in trying to estimate levels of completeness of birth registration. Okay, so I want to take a brief break here. Can I suggest we reconvene at 20 past, sorry, I'm trying to do the math in my head, 20 past 1 Bangkok time, so in 14 minutes, so I can grab myself a cup of coffee. And then we'll proceed with the last part of the last session of this training workshop before we reconvene again tomorrow for the final practical. So thank you very much.